So here is the data center behavior. We just summarize in this figure. As we can see, like the 7 months GPU consumption is very dynamic. Somehow, like even hardly to conclude any pattern, like the periodical patterns inside. And we can notice like the dynamic range can start from 0 to above 50 kilowatt. And also like there's a lot power spikes inside. And also once the GPU or the cluster got activated, the power consumption normally be above 10 kilowatts. And there's more like statistical insights. Like for example, the median power is around like a 30 kilowatt. This indicates the typical operation use about 50 or 60 GPUs. And also it has a very wide distribution. And also like somehow the curve is considerably smooth. And this means like the job is quite diverse. The jobs are very diverse. And also like for the distribution, the probabilistic density function, we can say a bi-model distribution somehow exists. And also in the low power mode, the peak is around like a 5 kilowatt. For the high power mode, the peak is around 30 kilowatt. And there's a long upper tail extend to like extremely high, but it's rarely happen during this data center data record. There's several noticeable moments, actually very interesting. I actually plot like more than 600 events, but 3 of them is a particular interesting to me. Like the first one, let me try to use my mouse here, like if anyone can see. Oh no, not I know. Okay, so let me just using my mouse to describe. So we can see a dynamic, like a sharp power swing, like from 70 kilowatt to 0. This is a very, very sharp and very quick dynamic change. This probably means like the model like running in the peak power level and then suddenly stop. And there's another example like showing like the sharp spikes following by quick returns to the baseline. Is the bottom right side. Like we see this continuously happen. Somehow like the model or the GPU just reached to a really high power consumption level and then drop back and then going to peak again and then drop back. And then we also observe some regular cycles, like those cycles between 20 kilowatts to 24 kilowatts. So if we dig deeper about this data center behavior, based on the MIT SuperCloud, the paper, this describe the jobs actually very diverse as we observe based on the statistical figures. Actually, it involves a lot of different AI algorithms, but this is not all of the computation. Well, for particular interest, we do notice we do want to highlight the BERT inside this data set. The BERT actually is a quite famous, very typical classical large language model. And this figure shows like the power consumption of the BERT. Actually, it can reach really high about this power consumption. The peak power consumption is around 50 kilowatts, and with average is around like 17 or 18 kilowatts. And this drop runs like roughly around 4 days. We can imagine like some research group must work on this data center and just for like for 4 days. So in detail, we can observe some interesting dynamic behavior inside. For example, like the power ramping can just happen at the beginning stage of the training, and the figure like upper right-hand side shows like the 20 kilowatt, roughly 20 kilowatt power ramping happen really quick. Oh, That's fine. Like somebody just jump in, like getting too excited. Okay, so the left bottom side, we also can observe some power decline happen, like a 26 kilowatt. And also we can observe like the power oscillation happen during certain time ranges.